Number 14. So this one's a little bit different from what we've been doing, but you can own, and this is going to be much more important if you are getting to calculus next year with me. It would be, you might take it in college, you never know. Okay, wow. Okay, but we did already cover this. We haven't covered it in probably like a month and a half, but you can still do it. Okay, so what you would need to do here is get a common denominator. So my first fraction has an x minus 1, but it needs to match the other fraction. So what does it need? An x. So I'm going to put an x on bottom. I'm going to put an x on top. Now the second fraction has an x, but it doesn't have an x minus 1. So I'm going to put it on top. I'm going to put it on bottom. Now, take a look at your two fractions. Do they have the same denominator?
Yes.
They both have an x minus 1. Then what that means is I can take it from two fractions, combine it to just be one fraction. So this is going to be one big fraction with an x minus 1 on the bottom. So far, so good? Okay, from there, we're going to combine the tops as well. So I have 2x minus. Then I need to take this negative 2 and distribute it in. So what is negative 2 times x?
2x.
Negative 2x. What's negative 2 times negative 1?
2.
Plus 2. And then what's going to happen on top if you have a 2x and a minus 2x?
Combine.
And that gives you what?
2x out.
2x, x minus 1 on the bottom. Good? So that's my final equation. That's what I'm going to do my Bobo, Bot, and Betsy on. So on the top, how many x's do you have? None. How many do you have on the bottom?
2.
X squared. Then where is it bigger? Bigger on top, bigger on bottom? Bottom. That makes it a Bobo. Bigger on bottom means the asymptote is 0. Can I have a horizontal asymptote and a slant asymptote?
No.
So I'm not going to have one of those. Now, the other thing I want to point out to you is that, remember, I think I mentioned this yesterday, the exam calls it an oblique asymptote. Those are the same. Okay? Holes. We need to factor cancel. Is anything going to cancel, though?
No.
There aren't any x's on the top. How can they cancel if they're not up there? So I'm going to put none. Okay, vertical asymptotes are x's that are left in the bottom. I have 2 x's left in the bottom. What's the x in the front going to give me? If it's in the front, what does it give you?
0.
0 and then 1. Now, if those are vertical asymptotes, I want you to draw them into your graph. So I'm going to have a vertical asymptote at 0. That's here. Can't touch it. Can't touch this. Do, 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 do. Do, do. Okay, you cannot touch that line. You can also not touch the 1 line. Now, the second thing, or the next thing you need to look for is the 0. 0 should be left over on the top. Were there any x's left on the top?
2, right?
None. Okay, from there, see, some of y'all picked it up, some of y'all didn't. I'm going to just graph it in here to see what it looks like. Okay, so here we go. I'm typing in y equals alpha y equals 2 over x minus 1. Okay, here we go. We're going to look at the graph. Ready? How many asymptotes should I see? 2. There's one of them. There's the other one, little bitty right there. I don't know if you can see it. And then there's the third one. Okay, so my graph looks like this. I have 1 here. I have 1 down here. And then I have 1 here. Okay, and remember, you have a calculator to be able to sketch those graphs. Okay, so I have 1 here, 1 here, and then 1 here in the middle. Okay? Now, let's review these little questions. My domain, how many x's can I not touch? 2 of them. What are they? 0 and 1. So I'll go from negative infinity till 0, union. 0 to 1, then I have to break it up again, union. and then 1 to infinity. Okay? I double checked on the exam tomorrow. It doesn't ask you for range. But your range on this one, what's the lowest I can go for these top two? 0 to infinity. And then your range on this guy, negative infinity to whatever this y value is. And you would just look on the graphs to see what that is. Okay? But it's not on your exam. Okay, last two sets of questions. As x goes to negative infinity, which end am I looking at, left or right? Okay, that's the left end. On the left end of the graph, where is it headed? What y value is it headed to? 0. What about on the right end of the graph? Headed to 0. As x approaches negative 1 from, actually that should be a positive 1. Switch it to a positive 1 there, because I want it to be at the asymptote. Okay, so here's my 1 asymptote. Which way is the left side pointed? Hint, left, right. Where's the left side pointed? Down, negative infinity. Where's the right side pointed? Up, so infinity. So the left side is going down towards the line. The right side is going up towards the line. So remember, at an asymptote, that's what you're checking. Okay? All right, turn the page. 1 page left. We can do it. Okay, even functions. They should be pointing same or opposite direction on the ends.
Same.
Even or same direction. What are odds? Opposite directions. Now, the other thing, and I did not stress this, but it is on your exam, even functions are symmetric across the y-axis, and odd functions are symmetric about the origin. And remember that what that means is you're going to have a rotational symmetry, to where if you spin it around like a fidget spinner, it should look the same. So we're just going to sketch the graphs here for the first two that don't have one. Square root x, you remember what it looks like? Looks like that. Is that symmetric about the y-axis for me to say that it's even? It doesn't have another side over here, right? So it's not symmetric about the y-axis. Can I spin it 180 degrees? 180 degrees is only half. So if I spin it, it would be here. Is that going to look the same in the same position? No, so this is a neither. Now, the other thing I said you can look at are the ends of the graph. How can my ends be going the same way when I only have one end? Right? That's another hint that it's a neither. Okay, look at B. What shape is an absolute value graph? V. The 5 shifts it which direction? Up or down? Up. So 1, 2, 3, 4, 5. Boom. V. Which way are my ends going? Same. That makes it what? Even. Also, where's your symmetry at? The y-axis. Draw your symmetry in. Okay? Look at letter C. Which way are both of my ends going?
Opposite, right?
They're both pointed down. So my ends are the same. That makes it what? Even. Also, draw in your symmetry. Do you see it? Okay, my sides match each other. That should always happen if it's even. Now, look at letter D. Is that symmetric on either side? No, but if it was a fidget spinner and I spun it around, would it look the same? Yes. Okay, if I took this shape and I spun it around, it would end up right on top of itself. So this has a rotational symmetry. That makes it what? Even or odd? Odd. Okay, the other thing that I can look at are the ends of the graph. Are they going the same way or opposite ways? That side's down, that side's up. They're going opposite directions. That also tells me it's odd. Okay? Last question. Oh, dang it. Almost said a bad word. Okay, domain. What x can I not touch?
5.
Okay, what is 5? 5 is the asymptote. What other x can I not touch? What x? Right here. Look at it. The whole. 4. Okay, remember that you cannot touch a whole or an asymptote. So for my domain, I'm going to have to break up twice. Negative infinity to 4, then 4 to 5, then 5 to infinity. Okay, why did I have to break up twice? This one's the whole, and then this one's the asymptote. Okay, remember, you cannot touch either one of those guys. Okay? Alright, now let's do the range. What y's can I not touch? Where's the y value of the whole? Okay, my whole is at 1. Where's my asymptote? 2. Then that means I can't touch either one of those. I can't touch 1, I can't touch 2. So negative infinity to 1 for the whole, 1 to 2. Okay? So 1 is the y value of the whole, and then 2 is where the horizontal asymptote is. So you're just paying attention to what are the numbers I can't touch, and then just make sure that those are in your thing. Now also keep in mind your exam is multiple choice. So you're going to look at it, find where the hole is. I think it's 25. It's not super long. Yeah, and most of them they give you a graph for, but if they don't give you a graph, what do you have? Calculator to look at it.
I'm not good at this C and E. I'm not good at that.
Okay, as x goes to negative infinity, which direction am I looking at? Left end or right end? Okay, negative infinity is the left end. What is the y value getting closer to on the left end of the graph? 2, because that's where the asymptote is. Remember, I'm going to get closer and closer and closer to 2, but I'm never going to touch it. What about x approaching 4? Well, 4 is here. What's my y value getting closer and closer to?
2.
What's the whole at 4?
1.
1. Okay? And so it doesn't matter that it's an open circle. If you're doing a limit, you're just looking where it should be. Okay, then x approaching 5 from the plus side, is that left or right? 5 is the right side. So if I'm looking at my x equals 5 line, this is the left side, this is the right side. So as I get closer on the right side, am I pointed up or down? Up to infinity. Okay, next one says f is continuous. Continuous means that I never have to worry about any x's I can't touch. Is that true?
No.
No. Continuous also, what I usually say is it means connected. So if I can draw it, oops, I circled the wrong one. If I can draw it without picking up my pencil, everything's connected, then it's continuous. Next one says f is always increasing.
No.
No. What's it doing here?
Decreasing.
Decreasing. What's it doing here?
Decreasing.
Decreasing. So that is false. It should be decreasing. Okay, then last one says f has a removable discontinuity at 5. What is a removable discontinuity? A hole.
Oh.
Remember, those are the same.
Hey, you're not an extra.
Okay, do I have a hole at 5 and a vertical asymptote at 4?
No.
They got it backwards. That's false. Okay, these guys should be backwards and then it will be fixed. The hole is at 4, the asymptote is at 5. Turn the page. Now the last page. Oh, good. These aren't so bad. Okay, 17, we have another picture. How many places we have to break it up at?
3.
3, what are they?
Negative 5. Well,
Negative 5, because I have an asymptote.
1.
1. And then where else?
That hole right there.
At negative 6. So I'd go from negative infinity to negative 6, because it came first. Then negative 6 to negative 5. After negative 5, the last one was till 1. And then from 1 till infinity. But remember, how do you do it? You just look for where your things are. -6, that was the hole. -5, that was the vertical asymptote. And then 1, that was the other vertical asymptote. So they're always going to chunk it up like that. You just have to look at the picture. Now, one more question. Why am I using parentheses instead of brackets? Because can I touch this asymptote?
No.
Can I touch the hole? No. That's why they're open. Okay? As x goes to infinity, am I looking at the right end or the left end?
The right.
Infinity is here. What are my y values getting closer to? What y value? 0. What about as x goes to -6? That's where my hole should be.
The left side.
-1, because I want the y value. It's -6, not -infinity. Otherwise, it would have been the left end. Okay, what about x approaching 1 from the left side? Well, 1's here. Here's my left side. Here's my right side. -infinity. The left side is pointed down. What about x approaching 1 from the right side?
Infinity.
That side's pointed up. Okay, remember the difference. You're just either on the left side of the asymptote or the right side of the asymptote. Okay, fill in the blanks. F of x has a removable discontinuity where? -6. And it has a vertical asymptote at -5 and 1.
Are we doing continuous?
Oh yeah. Is it continuous?
No.
Can I draw without picking up my pencil?
No.
No. Is it increasing?
No.
Which way is that going? Down, down, down. False. Okay, the last one. Okay, look at your little picture. Where are my zeros? What's a 0? Okay, a 0 is an x-intercept, so look at your picture. Where does it hit the x-axis?
5.5.
5.5 and
5.
5. Oops. -5.5 and 5. Okay, remember that a 0 and an x-intercept are the same thing. Okay, my domain, how far back does this side go? Put a little arrow on the end. -infinity, how far does that side go forward? Positive infinity. So -infinity to infinity or all real numbers, either one. Now, my range is lowest to highest. How low does my graph go?
Infinity.
Okay, but how high does it go?
5.
And then it stops. So I'd say -infinity to 5. This is the lowest it can go. This is the highest it can go. What type of endpoint do I make 5, open or closed? Closed. Because does it touch 5? Yes. What if it was an asymptote? Open. Yeah? Okay, then increasing means I want a positive slope. Okay, I'm going to shade on my picture when I have a positive slope. Do I start off with a positive slope?
No.
Okay, go left to right.
Okay.
Yes, this is increasing. Till when? -infinity till? Give me the x. 0. And then when is it decreasing?
0 to
Infinity. Yep. Okay? So for decreasing, you want a negative slope. Okay, the last question. If you have the picture, you should be able to write the polynomial based on where it touches the x-intercept. Count the zeros for me.
Is that a hole?
2, 0.
It is not a hole. It's just an ugly graph.
2, 0, and -2, 0.
Okay, 2, 0, and
2 squared.
that's -3, right? Now, if I tap the x-axis at -3, what is my parentheses? If I touch at -3, what is my x within the parentheses? An x plus 3. I'll come back to what you said in a second, Ariel. Okay, then my 2, it was a positive 2. What must the parentheses have been? X minus 2. Now, was either of those a double root?
No. Right?
Which one?
Oh, is that a bounce?
Okay, this is a bounce. Okay, it didn't pass through the x-axis. That means it's a double root. So I put a squared on it. So my x minus 2 needed to be squared. Okay, now, last thing I want you to do on this to make sure you got it. I want you to shade on your graph where my function is decreasing.
Do we not have to like put it in fraction form?
No. What do you mean by fraction form? You would only make it a fraction if you had a hole in the graph. So since we don't have a hole, you don't have to do that. When is my graph decreasing?
Infinity,
Till
like -1,
-1, and then where else?
2 to -1.
2 to infinity. So negative infinity to -1, union, and then 2 till infinity. Now remember, this is not a negative infinity because I don't care that it's pointed down. I care that it's pointed forward.
It's other way. Infinity, -1, 2 to -1. Right?
So it'd be negative infinity because that's to the left. Remember, for x's, you're always counting left and right. So this is all the way backwards till -1, and then 2 all the way forward. Okay? Great. So if your review is done, come show it to me at my desk, and then I'm going to give it right back to you so you have something to study. Okay, you have 20 more minutes. Yeah, if I have not already checked off your other reviews, then you can go ahead and give it to me. And don't all put the same time. Just give 20 minutes. Here? So -1 is this line. Oh wait, we changed.
Yes, that's just
So 1 is this line here. So this is the left side of the line. This is the right side of the line. So as x gets closer to the line, I'm on the left side. I'm getting closer and closer. My y is pointed versus on the right side as I get closer and closer where I'm going to go.
Hey, I didn't even do that.
So that's why this side is negative because it's down, and then that's. Does that make sense? Perfect. And then can I see, did you turn me yesterday? Or wait, not yesterday, the day before. Will you grab it?
Yes, sir.
I didn't get it. Who next? Let me see those reviews, or even one of you can just give me.
Wait, you can send a review part 1, 2.
You can wait. Off the ground. Do you want to finish?
My phone on forward.
Yeah. Yeah, but then you still do. Easy.
Okay,
Remember how to do it or no? You're just gonna plug in the number at the bottom and then count up to plug in the number. So like, I'll try it. You're gonna plug in and 2 times 1 plus 4, that's your first one. Okay, but we were number 2 times 2. Now I got extra 7. And then when you're done with making the list, you just add them all up.
Got the first piece.
Wait, what first page?
Oh, I have that.
Yeah, I have that. I put you
Wait, hold on. What are these service hours? What are they getting checked for, Abbott?
You're just like, I'm just trying to study.
Give me your little sheet.
Here, use mine.
Man, before it
Wait,
went.
no, don't turn it in. I'm not trying Darn it, I wasn't here yesterday, so I didn't see part 3, but I got one. Yeah,
He's still good.
Hang on, JB, I'm not ignoring you. I'm
Nah,
just
you was ignoring me. You was ignoring me.
Here you go, Captain.
Wait, here's y'all's.
Oh yeah, no.
Wait, did you put mine in there? That's not mine.
I'll take them off on.
Yasmin, you want this backpack?
Yeah.
Is that why you got this stick?
Yeah, like he has a charger. Like, I don't know why you supposed to for 8 hours not bring a charger. This one was never last.
That's your bitch ass up.
Seth, you don't want it back?
No, I want it back.
You do want it back?
I want my bag.
Let's leave it here. You don't have to as long as it's today.
Hey, you don't get that baby.
Then you already showed me your two.
Your shit's not even legible.
I don't have your two. Did you turn it in? Go look at your order. Okay, so make sure, can you do it?
I can do it.
Okay.
Oh, that's like.
Okay, thank you. Okay.
Wait. Done.
Hey, where'd you go?
Done.
You don't wear them, you sell them next.
Oh, you sell them?
Yeah.
Done. Everything's done.
Hey, come on, money man.
Don't shit be quiet if you sit there and
We can try it though.
No, okay.
It's fine. Oh, but you know I'm too damn skinny for that.
Yeah, I checked this.
Come on, that shit hurt.
My those are yours back.
I'll wait a buck
That's
Not big. Damn. Let me be skinny.
okay.
Let me be skinny. Like, I don't. Damn.
You go.
Did you hear that said, Brody?
Did you give it to me yesterday?
She got no ass
I
this
haven't.
bitch.
I don't have it. I will. So it made today.
I don't have.
There you go, Mr. Reed.
No, I'm saying like.
Oh, yeah.
Oh, he has it.
He wears the same clothes.
Here, I'm gonna give you
Nobody
some.
keeps.
Okay. You've been doing a lot more work lately. I want to see you pass your finals.
I got you. Slime
You're
bomb.
kind of like on fire, I guess.
Come on, crack.
Crack?
No, crack.
You say you're on crack?
No, I said I'm cracked, which means like, never mind. That was-
Like really good?
Yes, I'm really good. I'm feeling it. Hope you don't mind.
Okay, and then if you gave me your progress report yesterday, I'll type that in today. Anybody else have one to turn in?
Lex, oh boy, you tell him?
Oh, yeah.
Yeah.
Oh, we got all the time in the world.
Straight shot.
Thank you.
June said bomb up.
You don't got like a blue S on my
What's up? Bomb me up.
Are you up?
Find me up, Fletch.
Bomb me up.
Thank you, man.
Let's get a little wood.
Anybody else need me to check your review?
Oh yeah, me.
Okay.
Why you texting me like that, though?
It's you have 12 minutes.
You need to buy. Huh?
Don't start that.
And then Mitzi, you have your 1 and 2?
Yeah, they're in here.
Oh, they're in here.
What? So you hold me.
I'm gonna give it back to you.
So basically, you take it for your purposes.
Hey, wave check, wave check. Can I take a peek?
You got a little sad. You got a little Sammy.
Saturday. 2:30.
Now when you're your little
I'm gonna be a different man.
you bug. You insect. How did you get the name G-Bug? Because you see G-Bug in every facility.
Just told me
He's a junior. So what?
Holland,
told me he on court.
will you double check and see if you have your birthday? If not, I'll give you mine.
I thought there were a couple more.
Do you want my copy of it? You're good.
No, like, take it as no.
Just to look at it? Was it 1 and 2 or just 2?
Alright, bro, nigga, relax. You gave it something.
Yeah, let me just leave it out like that now. But when we said to have it, you can speak up. Yeah.
Okay.
Yeah.
Or you can even take pictures of it.
I knew it whenever you were to pick up.
You like this?
You didn't know when you wore that white shirt for this school?
Remember that we were